in the Aqueous Solutions chapter looking at our practice test A, and we're going to talk through the solutions of our third objective, all related to the term redox, oxidation and reduction. The first of our problems is asking us to assign oxidation numbers to atoms in the molecules and ions. Determining the oxidation number for the indicated element in each of the following. For example, with number 1, the carbon in the polyatomic ion called oxalate, C2O4-2. Looking at our rules for oxidation, rule number 3 had suggested, and I'm just going to write larger so we can see that clearly, C2O4-2. It says that we know oxygen is always a -2, except if it's in a peroxide, which this is not. It's a polyatomic ion known as oxalate. You can find it on your polyatomic chart. If oxygen's assigned a -2, the net negative coming from the oxygen, its total contribution is a -8. Rule 6 from our oxidation numbers would show us that polyatomic ions will add indeed to their charge a -2 in this case. That shows us that the net positive charge would have to be a 6. A +6 and a -8 adds to a -2. 2 units of the carbon, 6 divided by 2, each would have to be contributing a +3. Carbon in the oxalate polyatomic ion is a +3 charge. Number 2, As and As4, the arsenic. This happens to be the way this atom is found in its natural state, As4. Rule number 1 from our oxidation rules would show any element in its natural state is assigned a 0. Number 3 says, let's find O in K2O2. K2O2 is indeed a rule breaker for the oxygen rule. Oxygen is always a -2 unless it's in a peroxide form, as it is in this example. This is a compound, potassium peroxide. Potassium we know to be a +1. Its total charge would be a +2. Knowing that the total negative would have to be a -2. -2 divided by 2 gives this oxygen a -1 overall charge. Potassium peroxide, the oxygen is a -1. In the next compound, NaH, sodium hydride. This goes to rule 4 for assigning oxidation numbers. Hydrogen is assigned a +1 when hooked to nonmetals, and it's assigned a -1 when hooked to a metal. In this case, sodium, carrying a +1 charge, makes hydrogen a -1 charge. The hydride ion is a -1. Number 5. Here's a polyatomic ion called sulfate, SO4, carrying a -2 charge, the polyatomic ion sulfate. Well, we know oxygen to be a -2, so the total contribution from the oxygen is a -8. Polyatomic ions will add to the charge assigned to them, which in this case is a -2. Therefore, we can see the total positive must be a +6. Sulfur is a +6 in sulfate. The last example, another polyatomic ion called phosphate, PO4-3. On our polyatomic ion chart, PO4-3 is named phosphate. We know oxygen to be a -2, giving a total contribution from the oxygens to add to a -8. Overall, it must be a -3. So therefore, the positive charge, a +5. A +5 and a -8 land me at a -3. So a +5 is the oxidation state of phosphorus in phosphate.